Hi, my name is Graham Eber, and I've been investigating the impact of the tilapia, an invasive species in our local rivers and streams. In this documentary, we will investigate how the tilapia, a fish widely farmed for its resilience and affordability, is now posing a serious threat to our local freshwater species. With its rapid reproduction and adaptability, the tilapia is outcompeting our local freshwater species, disrupting ecosystems and endangering biodiversity. We will examine how this happened, its consequences, and what can be done to protect our native species. Behind me is the St. John's River, one of the rivers that's most affected by the tilapia. Rivers, the lifelines of our planet, teeming with diverse forms of life. But beneath this serene surface, a silent invader is wreaking havoc. A species sometimes introduced for agriculture have become a dominant presence in our nation's rivers and streams. Though beneficial for agriculture, are causing serious ecological imbalances. The tilapia fish, known for its laterally compressed body, deep shape, and long dorsal fin, it typically has a gray, silver, or greenish hue, sometimes with silver spots or gray stripes, sometimes with vertical stripes or spots, depending on the species. Its mouth is slightly protrusible, allowing it to gaze on a variety of food sources. The tilapia is highly adaptable and can thrive in diverse environments, including lakes, rivers, ponds, and even brackish water. It tolerates a wide range of temperatures and oxygen levels, making it a resilient species often used in agriculture. The tilapia reproduces through mouth burrowing, where the female carries fertilized eggs and young fry in her mouth for protection. They breed frequently, with some species spawning every few months, ensuring rapid population growth. It is primarily herbivorous or omnivorous, feeding on algae, plankton, and aquatic plants. It can also consume detritus and small invertebrates, making it an efficient and sustainable fish for farming. This is a video of the St. John's River approximately a year ago. As you will notice, the water is green, right? That is simply indicating that there's a presence of significant algae buildup in the river. Algae indicates an imbalance in the ecosystem of the river. It simply means that the algae has overgrown. In a stable or balanced ecosystem, certain living organisms in the river, algae and other waste and stuff like that, right? Now, because those organisms are dead, the algae is growing rapidly. There's nothing to control the growth of the algae. The algae basically now, it attaches itself onto other organisms in the river and will kill them all. There's significant damage to either most or all of the organisms that are supposed to be controlling or managing the ecosystem in this particular river. And that's what's going to happen from river to river, stream to stream, wherever this fish is. Some time ago, my son and I, we went to the river Tanteen, right, to catch crayfish. What was so startling is that when we threw our hooks into the water, right, what we were catching was actually tilapia. So I found it very strange. I never knew tilapia to be in that area, that Tanteen River, right? Also, what was also startling is that I noticed that the crayfishes that we were catching was approximately 3 inches, right, in length, the bigger ones. I didn't see any smaller crayfish because, for example, when we were younger, you would see all of the young crayfish coming out on the floor, right? The floor was, literally covered with crayfish, but we just weren't seeing any crayfish. All we were seeing is just tilapias. So that's what sparked my curiosity and led me to research this issue. So first, what I had to do to figure it out, I had to catch some tilapias, I had to catch some crayfish and put them in the same environment to see what would happen. Initially, I thought that the tilapias were eating the crayfish, right? That's what I expected to see. First of all, I had the tilapia in one bucket and the crayfish in another bucket. So I got a third bucket. I placed some of the crayfish, right, in the bucket with the tilapias, and I placed some of the tilapias in the bucket with the crayfish. Like I said, I was expecting to see the tilapia eat the crayfish, but that wasn't happening. The crayfish was just swimming around in the bucket. Tilapia was swimming and nothing was happening. So I kept on monitoring it over time. Eventually, what I noticed that the crayfish, the energy started slowing down, right? A few minutes later, it's like the crayfish just stopped moving, but they were alive. They were like stagnant. Some minutes later, I noticed that one started swimming toward the side. Eventually, the other started doing the same thing, you know, and within 30 to 45 minutes later, all of the crayfish in the bucket was dead, you know, which was, like I said, very shocking, you know. I had to sit down and ponder on it for a moment, right? I did the second experiment where I took the tilapias and put them in the water with the crayfish now. Same results. It's just that it took a longer time because there were no toxin in the water with the crayfish. As the tilapias were put into the bucket with the crayfish, after a while when the tilapia started releasing its toxin, its waste, I noticed the same result. The crayfish was starting to float up to the top of the bucket. They didn't want to go down where the tilapia were. And eventually they started floating toward the side and they all died. Behind me is the Grand Etang Lake. This is the area that I'm mostly concerned about, right, because of the fact that this lake is a major distributary for many of our major rivers, right? If you look, you will see that there are tilapias in this lake, which were placed here. They were introduced here. There are kois and other species of fish in here, right? In my opinion, that should not have been done. Koi is not a native species to our local rivers and streams, right? But again, we have to be very careful with that because we don't know the long-term effect that's going to have on the ecosystem, right? But what we know for now, right, the ecosystem wherever these fishes are being placed are dying, and the crayfish, many of us, we love our crayfish, including myself, they too are dying. That species is being threatened, right? So like I said, as long as the population grows, the water becomes more concentrated, it's death everywhere, death to every river, death to every stream. So one of the things that we probably can do is to start eating the tilapia. We will also have to remove them somehow to reduce the population. So every so often, remember they're going to hatch, right? And they hatch every few months and stuff like that. So we're going to have to find a way to reduce the population of the tilapia if we can get them all out of the lakes and the rivers, etc., etc. But something has to be done urgently. And also people have to remember the Ministry of Agriculture has to continue to sensitize people to let them know they can't take certain foreign species of animals or even plants and just place them into our ecosystem, because those species many times they don't have natural predators, right? So they grow fast. There is no control whatsoever, right? The Ministry of Agriculture have to consistently remind persons, whether it's plants or animals, they have to continue to remind and sensitize them that you can't just take it and put it into the ecosystem, you know, because remember the situation with the anaconda some time ago, right? God knows, you know, they got it in time. But yeah, so that's the situation.